When physicists study motion, they do not always begin by describing every part of an object. Look at this car. It has a front, a back, wheels, doors, windows, width, height, and length. It is a real body, with many parts. All of that is physically there. Now imagine trying to describe the motion of every one of those parts at the same time. Every wheel follows its own path. Every point on the body has its own position. Very quickly, the description becomes far more complicated than the question we actually wanted to answer, and even harder to visualize. Most of the time, we ask something simpler. How does the car, as one whole object, move along the road? For that question, we do not need every detail. We can replace the whole car with one single point, and let that point stand for the car as a whole. That is the level of detail we need for motion along a road. Of course, the real car is not a point. It still has size and shape. But when size and shape are not important for the question, physics lets us simplify. That simplification is called a model, a simpler picture of reality that keeps what matters and ignores what does not matter. The model is chosen for a purpose, not because we forgot the real object. When one point represents the whole body, including the mass of the whole body, we call it a material point. A material point is not a tiny ball hiding inside the object. It means that, while we describe the motion, we are choosing to ignore the object's size and shape. The point carries the information we need, where the whole body is as it moves through space. Here is a good example. Suppose a car travels from New York toward Boston. If we only want to know how far the car has traveled along the road, the exact length of the car does not matter. It does not matter whether the bumper is a little ahead of the trunk on that large scale. A single point moving along the route is enough to show the position of the car as a whole. But now change the question. Will the car fit into this garage? Suddenly the length and width of the car matter a lot. The space inside the garage cares about real dimensions, not just location as a whole. If we replaced the car with one point, the point would always fit. The real car might not. So here, the material point model is the wrong model. The rule is simple: use a point only when size and shape do not matter for the motion you are describing. Before using the material point model, ask, do the dimensions matter here? If no, the point model makes the problem clearer. If yes, keep the real body. That is the whole idea. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.